Hi, I'm Miguel Muski.
I'm Colton Misbach,
I'm Blake Johnson.
I'm Dante Windsor.
I'm Caleb Swanhart.
and we are the Formula Drift Knights Black Team, and this is our Senior Design Showcase presentation. I chose this project after following the automotive and Formula Drift communities for many years prior to the decision-making process of senior design. I was intrigued by the opportunity to work within the realm of FD and obtain hands-on experience with advanced composite materials and manufacturing methods.
I chose this project because I find composite manufacturing and fabrication to be an interesting topic. I previously worked with carbon fiber and fiberglass when I was on Florida International University's Panther Motorsports team and in high power rocketry with AIAA.
Hello, my name is Caleb Swanhart. When considering which project team I wanted to be a part of for senior design, this particular project stood out to me immediately. Automotive engineering has always been an interest and passion of mine ever since I was young, and to have the opportunity to work on a project in motorsports was an opportunity I could not pass up. Furthermore, I had been seeking experience working with composite materials and the manufacturing process with these composites, which this project stated would be a requirement early on.
I chose this project in particular because the overall nature of Pro-Am drift competitions piqued my interest. And as someone who has a fair share of manufacturing experience in the engineering industry, I was ecstatic to apply my skills towards fabricating an essential component for a motorized vehicle.
I selected this project due to its distinctive nature, setting it apart from others, with a deep-seated passion for cars and for the sport of Formula Drift. This project was a natural fit. The utilization of composite bodywork intrigued me as it promised to equip me with invaluable skills and experiences applicable beyond graduation, enriching my professional journey.
Formula Drift is a sport in which participants compete to score points by sliding or drifting their cars around a track in tandem with one another. In this project, the focus is to design a front bumper panel for a Pro-Amateur or Pro-Am spec Formula Drift car with the intent to compete in a future Pro-Am Formula Drift series. The primary goal is to use a composite material to manufacture a bumper which can withstand the frequent impacts the vehicle may experience, that being by elastically deforming and returning to its original shape without any permanent damage. Furthermore, this project serves as an exploration of composite materials and manufacturing methods in the pursuit of a technology which will permit the critical function of the product for the customer while also enhancing technologies currently in use.
Carbon fiber car panels are essential in motorsports for their lightweight, strength, and durability. They improve vehicle performance by reducing weight, enhancing handling, and increasing fuel efficiency. These panels also offer impact resistance, ensuring driver safety and lowering maintenance costs. Similarly, within the automotive industry for commercial applications, the reduction of permanent deformations due to small-scale impacts that would otherwise require expensive and labor-intensive repairs. Carbon fiber is also highly beneficial to aeronautical and aerospace implications due to its exceptional strength and lightweight properties. These advanced materials enable significant weight reductions in aircraft and spacecraft structures, enhancing fuel efficiency and performance. Additionally, carbon fiber's durability and resistance to corrosion make it ideal for withstanding the extreme conditions of space and high altitudes. Its versatility allows engineers to design sleeker and more aerodynamic shapes, optimizing the overall efficiency and safety of these vehicles.
A major roadblock for this project was budget. Originally, we were quoted to have a budget of $1,200, but were only initially approved for $600, which is then bumped up to $800. Because of this, the team was forced to pivot multiple times on the manufacturing approach. Initially, planning to take a direct offset mold using carbon Kevlar. After the initial approval came through, the team settled on an offset mold using carbon fiber, and when the budget was increased, a 3D printed mold using carbon fiber.
One of the major setbacks that delayed the bumper's completion was that the car was being sent to a ship to get vinyl wrapped. This is to match the overall aesthetic of being a UCF-oriented engineering project. However, this led to schedule conflicts between the team and the car's availability to get 3D scanned. Furthermore, we realized that we could potentially destroy the wrap with the surface treatment necessary to make the offset mold. Another major setback was acquiring a usable 3D scan to create a mold and conduct finite element analysis, commonly known as FEA. Even after multiple scan attempts using a Creality CR Scan Lizard and an OnStar scanner, we were not able to capture a complete scan of the bumper. However, we were able to manually recreate the bumper in CAD, which we were able to use for 3D printing and FEA.
Throughout the project, the team has made many significant achievements and accomplishments. Firstly, the team has completed a CAD model of the bumper. This was achieved by taking a 3D scan of an existing bumper and then creating segments and surfaces from the scan to have a complete model. From this model, the team completed the mold design of the bumper, which could be then 3D printed. Prior to the printing process, the team acquired all material required to complete the mold and the bumper through submitting purchase forms and checkout forms. With this material, the team then began 3D printing the mold and also made some coupons for tensile and flexural material testing. Each carbon fiber coupon was tested in Dr. Go's lab, and with the data found from testing, finite element analysis could be performed by the team on the bumper model. Finally, the team has started piecing together the 3D printed mold sections, which once complete, will be used to create the bumper.
Ready?